Okay, this is the homework from sections 2.4 and 2.5. We were given a function. We were asked to determine the absolute max, absolute min on this given interval. We have to put the interval in the table. That's our domain, nothing else. We differentiate the function. We get 4x cubed minus 6x squared. I factor out 2x squared, and I get 2x minus 3 in parentheses. Since it's degree 3, I expect 3 solutions. 2 of those are identical. X equals 0. The other one comes from here, 2x minus 3 equals 0, which means x equals 3 over 2. I put those solutions, those critical numbers, in the table. So these are the critical numbers. We don't know which ones change into max min. We'll see in a minute. So after that, we will study the sign of the derivative. There is no need to put any other numbers here but zeros and the symbols for the signs. There is no need to enter numbers in the row for the derivative other than the zeros. You can plug in a number between -2 and 0 and you'll see that this is negative. There is no need. This is always positive. This is a linear function with a positive slope. It will be 0 at 3/2, but negative and positive. So negative before 3/2, positive after 3/2. No numbers are necessary here. And then I have to plug in these numbers. The endpoints are mandatory into the function, as well as 0, as well as 3/2. After I plug in 1, 2, 3, 4 different numbers, I get these. Obviously this point, -2, 32, is the absolute maximum. 0, 0 is nothing. 3/2, -1.6875 is definitely the absolute minimum, but also the relative minimum. And 2, 0 is again nothing. Moving on, the same question for this function. When we differentiate it, and the domain is 0 to infinity. Obviously, the function is not defined at 0, so its derivative, of course, cannot be defined at 0. When I differentiate, I get this. X prime is 1 minus 3600 divided by x squared, because we know that 1 over x prime is -1 over x squared. Finally, least common denominator, so x squared minus 3600, factor out for simplicity here. I know that when I set f prime equal to 0, I get positive 60 and negative 60, but this is accepted because it's not in the given domain. So again, the sign is given only by this will always be positive. From 0 to infinity, this will always be positive. So it's only x minus 60. Again, the same thing, negative before 0, positive after. And when I determine the limit here to convince myself that this is coming from a higher value than 120, I do get infinity. So then 60, 120 is absolute minimum, and of course relative minimum as well. It's in the middle of the interval. Here we're asked to determine the maximum of this function. I change it into a product. Just me, because I don't have a variable at the top. Why bother then with the quotient rule if there is no variable at the top? So 1500 times this to -1. When I differentiate, I bring -1. I subtract 1 from the power, and I differentiate the inner function. And now when I rearrange the function, I get this. So obviously it will be 0 only when 2x minus 6 is 0 or x equals 3. I have to plug in here in the function in order to determine this value. There is no other number that needs to be put in the row for f prime other than 0 and the sign. I studied the sign. This is always positive, but there is a negative in front with 2x minus 6. So it will be from positive to negative. Or you plug in numbers, but not in this, just in the -2x minus 6 to save time. So yes, this is typical for a maximum. So that is the maximum profit. The average profit, we had to determine it as P of x over x. Profit is revenue minus cost divided by x. I copied the revenue. I subtracted each term in the cost, and then I divided by x each and every term. So this will be 400 divided by x, which is 400. This is -500 divided by x. And -1/2 x squared divided by x is -1/2 x. When I differentiate this, I get -1/2. This goes away. But now -1 over x prime is +1 over x squared. The least common denominator is 2x squared. This needs an x squared and this needs a 2. So negative x squared plus 10,000. When I set this equal to 0, of course, the numerator, I get plus or minus 100, and the answer is no. Only x equals 100 items. Now, I cannot take the negative. Algebraically, positive and negative are correct because this is quadratic. I have to find two solutions. But we're talking about number of items, so I can only choose positive. So between 0 and infinity, 100. When I study the sign of this expression, not the sign of this expression, because this is always positive, it's between negative 100 and 100 will be positive. So positive and negative. Or just plug in a number. Plug in 0, you get positive. Plug in 10,000, you'll get negative. So this is now typical for a maximum. So this is definitely a maximum. We showed that. Final question here. Find the maximum of some function with two variables, but we were given a relationship. I solved the relationship for y. I moved this term to the other side. I plugged it in and I distribute it. X times negative 4/3 x cubed now and positive 16x. When I differentiate this, I bring 3 in front, so it's 4x, negative 4x squared plus 16. I set it is equal to 0. I get positive and negative 2. We are given in the problem that numbers are positive, so I can only choose 2. So between 0 and infinity, I put 2 in there. The derivative is 0. I plugged in 2 to find y. So here, 4 times 4 is 16 divided by 3 plus 16. So this is, when I factor out 16, 1 minus 1/3, which is 2/3, 32/3. So if y is 32/3 and x equals 2, so here is 64/3. And this is a typical symbol for a relative maximum. Thank you.